Let's start this chapter with reflection, refraction, and the other related topics. Okay, so let's go to the chapter we want to talk about here. Is say this is the chapter related to optics. We call it the optics. Start with light. Okay, so light can be explained in terms of two natures. One is the nature is called, it is the wave nature. Based on that, we can define the phenomenon like interference, diffraction, and the other phenomenon like polarization. So this kind of thing can be explained by assuming that the light is a wave. Okay, the other way the light can be explained is by particle nature. Okay, in this here we assume that particles is the extreme of particles or photons, and with this is supported by photoelectric effect. Okay, so based on that, we can say that light or electromagnetic wave has as a dual nature. So sometimes to explain some phenomenon, the light behaves as a wave, and to explain certain physical phenomenon, it behaves as a particle. So we come to this point, and now this point later in the chapters, like light is a extreme of photons. Okay, so these are the photon particles. So each particle is called a photon. So each photon has energy. So each photon has energy of h times f. Okay, so you know that where h is the Planck's constant. Okay, so it is the Planck's constant, and f is the frequency. Okay, so f represents the frequency. So that's how this actually relates the wave nature and the particle nature. So the each photon has energy s times f, but we know that speed of light equals to f times lambda. So we can relate f as c over lambda. Based on that, we can say E equals hc over lambda. Okay, so this is the dual nature of light. So in this chapter, basically, we are not talking about the particle nature now. So let's talk that we are talking basically about the ray optics. Okay, so in ray optics, we assume that light travels in a straight line. Light travels in a straight line in a medium. Okay, so let's go here. Okay, so the light travels a straight line. To do the some mathematics and to make our topic easier, we assume some rays. So we are drawing the rays. Okay, so one, this is not real, but one is called the ray. Okay, if you as a complete is a collection of rays, we call it beam. So you know that ray gives direction of flow of energy. Okay, means, for example, light travels in a given way. For example, this arrow indicates that the light is traveling from left to right. Okay, so in this case, these all rays are parallel. So that's how we call this as a, in term of beam, we call it the parallel beam. Parallel beam. Okay, it could be possible that all the light, all the rays will be going from this source. So for example, this is the burning candle, the rays going outward everywhere. Okay, so rays indicates that the energy is traveling outward in this scenario. So in this case, this kind of beam is called the divergent beam. Okay, it could be possible that all the ray will come to a point. All the ray will come to a point. So for example, ray will be coming to from everywhere, coming to a point. Okay, so maybe all will be meeting at a particular point. So this kind of beam is called the convergent beam. Okay, is called the converging beam or convergent beam. Converging beam. Okay, so this is the combination of rays. So that's why the combination of rays, we call it beam. So let's talk about a simple situation. For example, this is a surface or a medium in between. Say we have this surface separates the two, this interface basically separates two media. Say up we have air, down we have say glass. Okay, so what will happen, just for simplicity, we are just taking a single ray. If we have one ray, so this is incident on the surface, that's why it is called the incident ray, because it's incident on the surface. It could be possible that some of the ray, some of the energy, some of the energy will get reflected back in the same medium. So you see that incident ray and reflected ray are in the same medium. So they are in both incident and reflected rays are in air. Okay, it could be possible that depending on the medium and interface, some part of the ray could go to the other medium. Okay, so this surface is basically interface that separates two media. It could be possible that some of the energy could move to the second medium. So this is called the refracted ray. Refracted ray. Okay, so you see that this refracted ray, in this case, in glass, in this scenario. It could be possible that some of the part could get absorbed. In this case, it could be possible that some could get absorbed by the medium somewhere here, either not reflected, not refracted. Okay, so the key point is that if you incident energy on a surface, what will happen? Some could be reflected depending on the medium. Some could be refracted, and some portion could be absorbed. Okay, absorbed by the medium. So this phenomenon could happen. Okay, so in this topic we are talking about basically reflection and the refraction. Okay, let's go to the topic. This is called the reflection. So you see that this is the incident ray, and this is the surface. Maybe the surface could be, say, this is, for example, say this could be mirror. Okay, this could be mirror. And you see here, this line is the perpendicular line to the surface at this point. So this point is called the point of incidence, where the incident ray strike the surface is called the point of incidence. At this point, we are just talking about reflection. So light is reflected again in air. So you see that incident ray, reflected ray, both are in air. Okay, so we can see here that we draw this line. This is the perpendicular to the surface. This means this makes angle of 90 degree with the surface. This angle is perpendicular. This angle is also, if it's the surface, this angle is also perpendicular. Okay, so based on that, we can write the laws. So this angle is theta I, this angle is theta R. So let's say theta I, we call it angle of incidence. Angle of incidence. Okay, so from the picture, this is clear that this is angle between normal and incident ray. Okay, and let's see theta R. Theta R is angle of reflection. Okay, angle of reflection. So from the picture, this is the angle between normal and reflected ray. Okay. So the law is the law of reflection is this: theta I is always equal to theta R. Okay, this is the one law of reflection. The other law, we can say that from the picture, incident ray, okay, reflected ray, and normal at the point of incidence. At the point of incidence, all will lie on the same plane. So these are the two laws of reflections. Okay, so these are the laws of reflection. So in the picture, you saw that this angle theta I is equals to this angle theta R. Okay, so this point is called the point of incidence. Okay, so this is the law we use to define the incident angle of incidence, angle of reflection kind of thing. So here you see in this picture this plane mirror. If we use the case of mirror, this beam is also parallel beam. Okay, parallel beam, which is incident. Because of the surface, after reflection, this is the reflected, is also parallel. You see here, this is also parallel beam. Okay, so this kind of reflection you see here, this kind of reflection is called the regular reflection. regular reflection. Okay, regular reflection. But the situation could be different depending on the surface. But here, if you see the beam incident, this is parallel. Okay, this is the incident one. Depending on the surface, now we are taking the sheet of paper, the reflected rays are not parallel. Okay, so these are the reflected. So they are not parallel here. You can see these are not parallel now. These are scattered. Okay, so this kind of reflection is called the diffused reflection. Diffused reflection. So we can see regular reflection and the diffused reflection depending on which kind of surface we are using. Okay, so but every time, whether regular or diffused reflection, laws of reflection is valid. Reflection is valid for both regular and diffused reflection. It will be true for both the reflection. Okay, so let's see how the image could be formed in reflection. So just for simplicity, just take a plane surface. This is a plane mirror. It's much easier. So, okay, so this is a plane mirror. Okay, so we put an object in front of the source. So this is a point object. Point object. Okay, we put the point object in front of the object. Okay, so you know that from this object, infinite ray will go out. This is infinite number. Okay, there are many rays. Infinite rays will be here. Okay, but to draw the image formation, we take just two rays. Okay, so we can take one ray. Okay, this is the first ray. So for the first ray, for the ray first, you can see your theta I is 0. If theta I is 0, your theta R will also be 0. So means incident ray and reflected ray will return back through the same point, same line. Okay, so this means we can produce back. If this is the space available, it will go like this. Okay, so here you see that this one, let's draw the other ray also. Let's draw the other ray 2. 1 and 2 are incident rays. Okay, incident rays. We need, so to draw the diagram, we need at least 2 rays, 2 incident rays. Okay, so I took 1. So you know that in this case, for the ray 1, angle theta is 0 degree, and according to laws of reflection, theta R also is 0. But this is not the case for the ray 2. For the ray 2, your theta I will be something. Okay, so for example, this angle could be a theta. angle of incidence is theta. So this means if you draw the perpendicular at this point, this angle is also theta. According to law of reflection, reflected ray will go this way because it cannot go backward. So 2 prime is the reflected ray. So in this case, you see, you can see that 1 prime and 2 prime are reflected rays. Reflected rays. Okay. You see, the 2 reflected rays can't meet. So from this picture, 1 prime and 2 prime can't meet. So we are going to produce back. If you produce back, this will be here. So the reflected rays can't meet if produced forward, but they are going to meet at this point. So this, but they can't meet in, but they meet virtually. In what sense virtually? We are producing back. So this O prime here is this is the virtual image. Virtual image. Okay. This is a virtual image. This is not, so this is not formed by the actual intersection. So because this image is virtual in the sense that actually virtual reflected rays intersect. That's the reason the image is virtual. So the image we see in the plane mirror is not the real image. This is the virtual image. Okay. Next, I want to show you that what is the minimum size of the mirror so that we can see the full image. So this means, say for example, if the person height, say for example, the person height from here to here is 2 meters, then the mirror size must be 1 meter to see full image. Okay. So I'm going to show you one demo or the simulation. Let's say in this simulation, you will see that the object height is 50 centimeter. Okay, so let's annotate here. This size is 50 centimeter. Then image size is also 50 centimeters. So in the plane mirror, the height of the object and height of the image will not change. So object distance means from this location to this location, distance between mirror and object is 139. Image distance is also 139. Minus is only to indicate this is the virtual. So this minus sign indicates that image is virtual. Okay. This is the virtual image that's showing you. Okay. So you can change here. For example, if I change this position, every time you see height of image and height of object will remain the same. So this means we need fixed size of image, fixed size of mirror to get the full image. Okay. And the other simulation I will show you here is about the angle of incidence. Say for example, I'm changing angle of incidence, say for example, for the object at A. You see, in this case, you can see in this case that the angle changed, angle of incidence is 12 degree and angle of reflection is also 12 degree. Okay, let's move that to the position B. Okay, let's move to the position B. You see angle of incidence is 67 and angle of reflection is also 67. Okay, so this means angle of incidence and angle of reflection is always same. So for example, for the position at I, angle of incidence is 7, angle of reflection is also 7. Okay, so this demo will telling you that angle of incidence and angle of reflection is same every time. So if you understand up to this point, you can study this picture and you can answer this practice question number 1. Okay.